Okay, so welcome everyone to this new episode of EagleFly, the experimental debugger. Uh, Today we will continue on the thing we left off. That was, if I believe, uh, debugging. Well, we were implementing the tracing of messages from the target process. And there's an idea that I got, that probably we can use, and I would like to explain it to you. It's some architecture concern. So let me draw it to you. We can do this. Let me see where, because we have a bunch of stuff here. Let me start somewhere free, like here, I guess. And if you remember, well, I don't know, but we had some kind of stack there thing, but I remember that we had some kind of image there. Well, this is the update number 2, Oh, this is gonna be the update. So the thing that I was thinking on is like, well, we have a thread, and this thread is the one in charge of making up the all the tracing. It's basically all this tracing thing. So we have something like we have like the tracer here, and the tracer is just, it's the one in charge for and let me put it right here, because I probably want to and again right here. I'm gonna put here the things that we at least for basic we want in this debugger. One is that we can save the state. One of the most important. We want to get it easy to save the state. Second, if possible, I want to serialize. What I want to serialize is the code flow and how does this thing goes, because right now it runs in parallel, and probably that's what the thing that we are gonna take a look right now before going further into a tracer. I want to see if we can serialize the code flow. I know it's kind of crazy, but if we can do it, it's gonna save you a lot of problems, and I'll tell you why. Because we will need to have any logs or any kind of integrate crazy stuff that are happening. That probably is the thing that we want. So we want to serialize. This is really, really important. We want to have the capacity to save the state of the variables, watch windows, anything all about the debugger should want to, and everything. Since this is a really how can I say, user intensive, UI intensive, or event driven thing. I want to say event driven, but I just want to say the difference between, for example, debugger and the game, and a game, for example, that the game it's constantly updating the frame in a loop, whereas probably we don't want to update the frame every time. Uh, Only on input stuff, for example. We can go that route. We could if we want. We can. That's not important. I mean, we could if it's more like a performance stuff. I can put it there, but so it's really like performance or more draw on input demand. And I believe, and yeah, I think, well, if I think that's all. I mean there are 3 points here, but I just want to mention it because these are the specific things that we have to take a look about this thing, you know. And so if I keep that in mind, this is the idea that I would like to see. So since we wanna, I mean, and probably this is the one that, and draw input demand, and also especially these two fellas are the one that drive the user, or drive this kind of architecture. But let me explain it to you. This is a tracer, and what I want about the tracer, and the thing that I have right now, is that the tracer is the only one in charge of connecting with the target application. And the only work that he has to do is to send us back when does the application or the target application has sent us some message, you know. So the tracer is going to receive the message. Receive. And receive messages, and do commands or execute commands. Like writings and stuff like that. Readings. So those two are the main jobs for the tracer: receive messages and execute commands. Besides that, he doesn't care about anything at all. So all these messages and comments have to be given by what I would say. I mean, and here, for example, let me see. We have the input. Well, this is the input, and the input is very important because the input drives these two kind of drives. If we say like draw an input demand, it will drive the render codes, and it will drive also the tracer data. That, I mean, it has like this kind of bifurcation, you know, that it has to control both this. So to simplify this stuff, what I would like to do, because let me put here, I'm gonna have the renderer. we have the render, and let me raise this because I don't need that. So we have the input and the tracer. So it would be nice to have some kind of a manager here, you know. And the debug manager basically, I mean, can be like, I mean, it's gonna be a bunch of stuff there, but it's basically is the one in responsible. This debug manager is the one in charge of saving the state. You know, this fella is gonna be the one that saves the state and be in charge of what commands are going on into the tracer specifically. So it's gonna be giving commands to the tracer and receiving the messages from the tracer, basically. So that the debug manager is gonna be in charge of processing those messages and executing the commands that, based on the input, it's gonna happen, you know. So the input, yeah. So that what I like about this is that the input passes through this process, and depending on what I mean this thing does, you can pass the input data information to the tracer or to the renderer as needed. And I mean, I can do it like this. But there's some caveat to this, and it's just like probably we also want to, I mean, we don't want, I mean, I don't want the debug manager to have the whole kind of UL elements and stuff, you know. So we probably want some kind of UI system here. That basically is going to receive the input being processed from the debug manager, if it receives anything, and then the UI system is the one in charge of connecting to the render itself. And yeah, some kind of there, you know, some kind of that's the idea that I got. And the reason that I like this more is because now, I mean, it's simplified. We oversimplify. Well, we weren't taking into account the input stuff. That was the main point. And the input stuff, I like this because it's kind of a, we don't want to get bananas out of the input stuff, because if we have these two threads going on, getting to synchronize them based on the input that they got, it would be crazy if we don't take proper logs or stuff, you know. So if we have the possibility to make like this kind of architecture where everything is serialized, except for the input, of course, but everything here is serialized, so that we get, I mean, and the key point here is the debug manager. The debug manager is going to be in charge of making and processing the input to different parts of the system, to the tracer and to the UI system itself. In that way, we have this one-spot decision where everything that process, the tracer and the UI system will know that the state of the input per se is going to be the same, and that's really important, because we don't want to have differences in the UI system. And also as the well, because the input comes from here all the time, and because this is like in a loop way, like this is like a loop that comes back. And well, I mean, it's not that the renderer gets connected with the input, but you get the idea, isn't it? I mean, there's a loop like going in here. And so, I mean, right here I don't have the run input demand thing, but I don't think that's like totally hard to implement in this kind of architecture. So yeah, I mean, if we can try to do that kind of architecture, I think we'll have a better chance to simplifying how input stuff gets processed across different steps. So the key part here, and now that I've explained this kind of architecture, I would like to go to the code, and the first thing that I would like to do to make this happen is to, where is it? Here is EagleFly tracer, and I would like to go to EagleFly, and this is what we will do. Wait to window call back. No, this is not. This is the. So the first thing that I want to try out, and this is the crucial part, because yeah, let me go. So before we have this, where is it? This thing where we create the thread, and I mean, as a first thought, it was kind of it was reasonable, because since we don't know what the process itself is doing or whatever. And let me tell you the caveat about this, because the whole thing about this, and the reason that I want to, and the caveat is that if we remove the thread itself, so that we don't do anything of this at all, imagine that we don't do that, and instead we do everything serialized within the loop, So if we go back here, and just after we process the method to load, what is the input? Debug process. Here you go. Right here, we can control keys toggle. This is for the loop like coding. This is for the reprocessing of the message, and the mouse messages, and the mouse position, and if it's recording, we process and we get the input. So probably this is on the low, probably right here. So right here, we're gonna do basically this. So in this way, and probably I will need to I don't remember what was it. It was like this state, I guess. Probably we can pass some input. It was the new input, and probably we want to, and this, I like this because we will get basically the same layout from the thing from loop like code editing stuff, which I don't know if we want, but I mean, probably it's kind of it's kind of ridiculous to have loop like code editing things going on with the things, but man, I mean, believe me, it's not that crazy. But I mean, the thing about the thing that I like about this is that it's super direct, super in line with the things that we're doing. And the thing that I would like to do here is like, okay, we're now gonna call debug tracer callback, and it's gonna receive the new input, or the we can have this kind of the same thing, So I don't know if we want that, but we can do it. Doesn't matter. So the point here is that we're gonna do this call, and this call is gonna basically reprocess everything. And the thing that we'll need to do to make this possible is, instead of making let me see, and let me just, before going and making this, so the thing, we will process the whatever the target gets us to us, give me that, or get me that, and save the state, or whatever. And then we will do some kind of a we get the information from the tracer, we get some information, and then we process it somehow, and probably that can go to the renderer itself, debug renderer, and the renderer will go and make the whole UI stuff and stuff like that, and the render itself, which I think this is the way we probably want to test it, so through here, everything, the calls and stuff like that, it's like making sense. Alright, so let me think. Okay, we can do that if I compile. What's this? And now, well, let me see if we can do this way. What was that? Because well, we don't care too much about this, I guess, because we are not handling right now. So we can do that. So basically this is gonna do this way. And probably well, yeah, it's okay. This is this step, and the and 132 input, or it was it was debug input. So we don't need to do this at all. This is the result. I don't remember what the result was for. It was because it was something. So we can do something more like this, and we can do something like this, and we can get the data. And now this data, well, we can leave it like that right now, but and the thing here is that we will process the information, and now we will like so now here's where the cool part comes, you know. We want to do something like if this state is not initialized, basically the whole thing is going to be going on for that. But no, sorry, it's going to be something like, where do we create the process? Right here. So we probably want to do something more like this, and it's more like this, I guess. We're gonna get that, and can do it like that, and then we can. Right now we are only debugging main process, not shell processes, okay? And then this is probably this is the process execute, and I don't know if we want two different states for it, because we want to initialize it. I mean, probably we want to initialize this stuff based on some kind of input stuff, you know. So we have to something like this. If this state initialize init process, this state where is it, and this is this state process is running equal true, what process is running, blah blah, and this is not the while anymore, because it's probably more like an if. And now we can get, what is this? This is the process execute. We can move that. Well, yeah, because it's gonna be in this state, so we can do something like this, and then we probably want to try to, we're gonna get some data, and probably, I don't know if we want this to be directly, because I mean, I just say that this state is in a process, which I think I like more than like getting the input stuff or whatever. But you know what, one step at a time, I guess. So for now, I guess I would do it here, and you know, it's gonna be something like this step in the process, and then the state process is running, and probably we want to do this something more like it's gonna be something more like this. So that this goes right here. And we probably want to do this something more like this is going to be a separate thing where we to do any proper this the local variables is needed. I'm sorry, let me go and put the charger on. And yeah, I mean, I think I'm liking this code, you know. It's way more simpler, super simple to think about. We don't have this kind of crazy thread going on there. And now we can display the state, local variables is needed, okay, yeah. We can process exit code. And we can have something here like we don't need any states. We can have this state went through to dispatcher state, went through to dispatcher state, went through to memory, debug. I don't know, probably it's tracer storage. Memory tracer storage, yeah, something like that. And something like that. And I don't know what we want to do for the input data, but for now I'm gonna leave it right there because we don't know. So this the process execute, and yeah, so we took out here, we initialize the process if we want to, and we know that it's not running, and we process is running, and then we go back and process the events as please. So the thing we like to do here is, instead of doing it infinitely, we would not wait at all, you know, so that if we don't care if we don't get it. If we don't get it, then we don't process anything, which is nice. But if we do, and if we encounter a debug event upon the same syntax state, and this is a caveat about quitting the thread. Now the what I'm thinking on, and this is because I have to read more about it, but I'm expecting this to have a queue message thing as Windows procedure, for example. But I think we read something about that, isn't it? That Windows had this kind of a queue system that we can just wait for the bug event, and wait for the bug event will get us that thing, you know. And I think that's kind of nice, you know, because even though it's not like kind of real-time stuff, it's more like we'll process it whenever we get it, you know, or whenever we pass through it, and I think I like that more. So with this in mind, now we won't wait anything. We just like, hey man, we got it, give it to me, I will process it. And now I think it would be the same here. The same, this is for the exception stuff, that we don't do anything at all with this. This is for the debug string. I mean, right now we don't basically do very much of it, you know, but and this continue, it has just to happen when the if happen, you know, because that's the only place where it should be. And right here, let me see if I can take a look at this. To see the matching braces. So this is the cases, this is the switch, and this is the wait. Perfect. So it gets matched. Okay. So now that we got it this way, I would like to see if everything goes the same route. We'll have a tracer storage, which probably we want. I was thinking like probably we use the transient, but I would like to keep the transient more for the UI system and stuff like that, because the debug storage is going to be permanent storage, as for the things that I just explained. So the debug manager is the one in charge of that. The transient storage is more like for processing stuff and whatever other thing we want to do with it, just a playground. And I would like another one here. And it's initialize. I would like to I will basically want to kind of initialize the data, yeah. go here. So the process info, it would be something that we catch, and the process info, we get it to what's this? Yeah, we could have the process info there, and we would like to And now we don't want to close the handle right here. Probably we want to or probably I could do it right here. I don't think there's a problem for doing it like for close handles, if I remember. we should do this, or the one that's gonna be in charge of that's gonna be the continue debug van. Okay, so probably it's more to keep it without it, I believe. We don't return anything at all. The debug memory. And alright, so now the thing that I would like to do is to initialize the memory right here. for the tracer, I don't know. Something like that. And then I would like to compile, and then I would like to go to the tracer, and I would like to say that I don't know, well, uh, 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 what can I do? Well, for now, I don't know if we want to do this. Probably, what do we have on the input data? What do we use it for? We use it just for this. So we need to set that also. So what I like to see, because it's something that we don't know how to handle it right now, but we can say something like we have the target, and we basically mm, 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 input data run from command line. equals input data target full path blah input data command exe full path. This state is initialize equal to true, and this is gonna be target full path cmd exe full path, and then I guess that's it. And we have that, we have this, and we probably want to do something with this, so I want to put it right here, and yeah, so probably we want to pass it target full path car point target full path, and we got the cmd full path. There you go. And probably this is more like this is more like debug the tracer. And then we have that, and J and compile. We'll have that. So probably this is gonna be can be this target target and then we like to pass the data that we have, so it would be, where is it, is this one, so we don't need that at all. but in fact we can do this. And how is it called? Target back command exe full back. Alright, so let's see what we got. EagleFly tracer, we got something like that. We process the events as we need to, inline do, and let's see what we got. This state process running. For now, process running, and let me see. Something like that, I guess. Okay, so let me go into the process. This is not the process, this is the process, and I would like to store everything is busted now. There you go. And I will see. Yeah, I want to save the whole thing. No. I like to step into here because I don't know what we got. And let me see if we can process. We have this state, which is basically, well, at this state. There you go. We have something there. There's serial at all, but it's not initialized, of course. And now we have to step into this process. In the process, I want to initialize that process is initialized true, and not process is running. Process is not running. We will start the process with the target full path. This is bview test debug target.exe, which is fine, and the command.exe full path is C Windows System 32 command.exe. Perfect. So we come running. We say hey, you know, this is the thing. We say the command, but the command needs nothing, so nothing should go. And we say hey. Oh. And this would be sorry, and we have to change that, because what I meant is more like this. breakpoint back. We got the process, we got the target name, which is tells debug target.exe, the command, there you go. What about process is running? It's true. We got the process, we can continue, and we start to do the same thing. We wait, we didn't wait at all, so now we got something. It seems that we got it, and it's even code there, and we process it as we might expect. It's a create process. Okay, now it's gonna print it, the buffer, which is fine, which is what we expected. Process ID, thread, blah blah blah, blah blah blah, blah blah blah, blah 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 blah. String address, 0x, blah blah blah. Okay, that seems very good. Now F10, I'm gonna continue, and then continue. We continue status, which I don't think we had it anymore. Nope, but it's okay. Oh, Jesus. Now we get it, we update the render. Oh, no. Which is the thing normal. That's normal, and we can go with 5, and then go to the next route and say process me. Yeah, process is running. Wait for debug event. Debug event code. Oh, we got another event, I guess. Now what about this event? This event is 6. Okay, I don't know what's that, but take a look. It says load DLL, so we can print it out, and it's a DLL. Good, and we can continue. It's gonna do basically the same stuff. 5, continue. It's another load DLL. There you go, we got it. Continue. Okay, so it seems to be working. There you go, we have a big bill. And we have both of the windows running, which is nice. That's what we want. Good. And we can continue. 5. There you go. Continue. We keep getting this. This is the first breakpoint that we done dispatch, but the continue status is gonna be oh, it's because because we handle it like a breakpoint bed. We don't do anything at all. Okay, it was a breakpoint stop. Okay, so I believe, I don't know, we can take that later. We continue 5, continue. Now we have the output debug string. We got it, there you go. This is the first thread. So there you go. We are properly running, but now we're not getting any signals. And there you go. And we have both of them, one for the other. And you know, this is kind of crazy, isn't it? Alright, so yeah, it works. There you go, it works. Awesome. So now we have a serialized way to handle the input, the tracer stuff. And man, this is gonna save us a lot of pain in the ass, you know. Everything that works exactly the same, because hey, we have the queue and the queue just dispatches. And awesome. Okay, so now what I would like to do is to well, we don't get anything there, I guess. To continue, you know, now that we had that, we can continue and process some good stuff there. Alright, I like it. So very fine. We can pass the input stuff, which is nice. Let me see. Oh, so yeah, now the thing that I would like to do, this is gonna be really funny. Let me try. Yeah, because the thing that we left off before doing all this stuff was that we want to set a breakpoint at the first part of the address, you know. So now let's play with that. Now that we have like the proper architecture way, we can start to construct it. It's simpler now to construct it, you know. So let me see. We have a breakpoint here. I don't know what we want to do here, but let me put next 1.5 just for checking out that. And now I would like to go and get the now the problem that we were having is that whenever we step into the F10 here and we get the disassembly, we got this address space, you know, that is blah, and probably I mean, we can start by there. I don't know if we output debug string hello from test. I don't remember if in the scratch it's the same. Is 6a, it's none of them, I believe, but this is the main entry function, which probably is not the one that we're gonna get, because I mean this is not the base entry point, because if we go to EagleFly tracer, so yeah, we have to check. I mean, if something goes wrong, I mean, we have a caveat there with the inlining thing, and is that if something goes wrong with the dispatcher, the render is gonna go out and everything is gonna be broken. But that's why we have to take care about it. So I don't think it's gonna be. I mean, since we're only getting data from it, I don't think there should be much of a problem. But we have to take a look. So this is the address, and this address changes all the time. It's not the same. We can see here. It changes. The code bats, they look the same, 2410, but the address changes, and of course the base address is not going to be there. So probably what I like to say is that we have exception there, we have the create process there, and now I want to get LP store address, and I would like to do something like that. And for now, probably we want to do something better here, like get store address here, something like this, and the events of, so probably we want to do something like that. And okay, so imagine that we got star address. Now what we can do is to read, how is it called, read memory, it was read memory, read process memory, and where was it? I want basically this. like to and then, I mean, basically what I'm gonna do here is I'm gonna get the instruction, which is basically this. This is the instruction we are looking for, all this stuff, and I want to modify the first by to CC, which is the instruction to is the debugger lock, and so we can create an exception. So what I like to do is that I wanted this the process is there, and this is the address. I don't remember what reprocess memory was. Reprocess memory is gonna be okay, got the base address, we got the buffer where we want to store that thing, the size, and number of bytes read. A pointer to the value represents the number of bytes read. Okay, perfect. So is that word? No, it's a site T. Okay. And this is 1, and this is gonna be U8 well, probably we want to do something better later, but it's gonna be the byte, but this is the how can I call it, is the original code byte, and original code byte, debug string, a bit, debug string data. And I mean, I'm not doing, I mean, this is not any kind of performance oriented, because we're reading the bytes, and that's super not the thing that we should do, but you know, that's right for now. This is the place where we wanna go into, and this is gonna be this date at, and probably adds to not probably no, it's not like the best thing to do. Probably more like this state memory address, process address, C process address, current process. I like it. And yeah, I think that's good. Fail, get current address B. Of course, we want to do this. Okay, now it's missing get store address. So after we process the memory and read it, we got it on the original code, but I would like to write process memory now. I don't know what this gets into. pointer to the buffer that contains data to be written in the address space. It's gonna be 1, and this is I don't remember if it was CC or what does let me see. Let me see. Let me see. Do, 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 do. To 4. Okay, so yeah. So now that now that we wrote this process memory, we wrote the interrupt callback, we can flush the instruction cache. So, and this is for safety for us, because we don't know if the process has already got some cache, some memory inside the cache, and it's not gonna process our new instruction being set. So we want to flush instruction cache. Well, let me. We got the handle to the process, the current address, and the size. There we go. Mm, mm, mm. There are Uint 18. This is the get store address that we don't have right now, so it's right. So yeah, so basically if we run this, we should get an exception that and I don't know if we have to continue after this, but that, yeah, that would be done by the by continuing this way, continue debug ban, which is fine. Okay, so now let's see if we can and the problem is that right now we don't have a way to show how to get the address, you know. That's the only problem that we have right now. And you know, right now let me implement it just because why not. I'm gonna put it and probably this is 32 get process star address. There we go. 32 dispatcher state and the debug event. It's a debug event. And probably, yeah, this is a pointer also. And we should I don't know, bullet pointer, so cool. This day, well, now the thing, we can do it like this. Now I can do it like this, I guess. So out debug event, and probably this is not debug event, more like debug event, how is it called? It's the debug event, because we don't want to do that everywhere, so we want to pass exactly with process debug info. It depends. It depends. For now, we're just gonna probably gonna start this because we don't want to do it anywhere else. So let me that has to be equal to create process debug event. If not, don't do anything at all. Please tell me that I'm doing something busted and I will handle it. So create process info is the name of that with a U, and the create process info has an LP star address, and that for now we're gonna do that. And the thing is, like, let me put it to do, because LP star address is busted. We need to find a better to get the real process start address. So yeah, so for now I'm gonna do it that way, and we compile. If we compile, let me see what we did. We this is a pointer. All right, so let me close this. Now the one thing I don't know is that test debug target will Jesus Christ. No. Now, I was just want to run these because, yeah, just to be sure. All right. So what I would like to do now is to run this, and I would like to stop on probably. Here, I guess. I want something here so we know that we are entering here. I want something in the place where we are doing this thing. No, it's not that. It's right here. And it's kind of a hustle to be doing all this stuff all the time. I hate you. No, I don't want that. Mr. Visual Studio got mad on me. Man, what can you do? It's real. I mean, the thing that I have to set the breakpoints all the time just gets me busted. Puts a bug on Mayor, you know? Let me see. Jesus Christ. I mean, I have to put the whole breakpoints there. I mean, I just want to say, put me all the breakpoints and put it on me. Put me all the breakpoints. Alright. So please, Mr. Debugger. And now where's the place where we create the process? Here you go. This is the place where we should look at it. So let me go. Here you go. We create a process and we want to step into here. We say, hey, this is a process. And if we well, no, we want to F11. The start address is gonna be that. You know, F10, and if we run this, we get this, which is by no means the same. Almost the same, almost, but this is a little bit busted. So we probably are gonna modify something that is not even there. But for testers it's gonna be okay, because I mean we don't care if we don't stop exactly there. We're gonna stop probably man, Jesus Christ, this probably we are not gonna stop even somewhere near. Jesus, what's going on here? Probably it's not even gonna work, I guess. Yeah, because it's gonna stop here, you know, and we don't have anything here. It's 1360. We don't even get right there. Here you go. 136. Oh, here you go. This is the place where main serial time startup. Yeah, so this is a place where we are gonna stop. Awesome. So this is the place. I was like, where am I gonna stop? Where am I gonna stop? And if I do this, can I not copy this main zero time startup? In fact, let me look at it. What I don't understand is that, I mean, what are those pointers? Are they the pointers to functions? And where's the, I mean, the initializer should be GI, isn't it? This is the, yeah, the group for the initializer, global initializers, which is that. So first it comes XA. Okay, so XA is a pointer, and XC is the other pointer. And then you have two global initializers, which I don't know. Well, probably yeah, because func has to have a global initializer, and GI also. Oh, okay. So this is the way that they will be laid out in memory when the image is loaded. Cool. Okay, so we know that this is the entry point. So let's go back to the place where we were doing all this stuff, and I wanna say that I am gonna continue. So I think it's fine. Probably is not the place where we want to start, because let me see, can I modify that? Because what we are gonna modify is this, see? This code by. So this is the thing that we're going to modify. Scratch. Let me cut. Oh no. We'll modify this thing. Are you serious? Can I copy this? Come on, let me copy. There you go. It's kind of hilarious, this thing. Okay, this is the callback, and we should set it to CC, you know. So we're gonna set it to CC and the same stuff. All right. Are you ready? Let's go. Ah! Oh my things were these were made which cannot be compiled, but cleaners to continue with applying the dits. Ignore. It no longer matches the version of the values, blah 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 blah. Yeah, I don't care. I don't care, my darling. Just want to continue. And now I want to process the memory, and it couldn't do it. Oh man, okay. Let me try again. Yeah, let me try again. We can go that way. No. Compile. Perfect. We are there. Please, mister, do your magic. Alright. Git process start address, which and there you go, and the current address. What? I forgot that I did it that way. Okay, so the thing that I want to do is more like this. I don't know if I like it more like, I think I like it more this way, you know. No, I wanna do that. There we go. I put the string. Okay. Okay. Now current address should be something, you know. And I would like to continue. We could read the app process, and original code path is 72. Okay, whatever it is. It was not something different, I don't remember. Well, let me put it here, I guess. Original code path in hex. It's 48, so yeah, it's correct. Because it was 48 at the beginning. Yeah, perfect. So now I would like to continue and tell that I want the interrupt callback. That's basically cc and 0xcc is in 204. Perfect. F10. We could write it. We will flush instruction cache. And now I don't know what's gonna happen. Continue. We have a loading. 10. Continue. 5. There you go. We got the breakpoint. I think. Oh, and this is the first breakpoint. Okay, it's perfect. We got it. I believe this is the first breakpoint. So we should well, not do anything, I guess. Continue. This is the one that we got. This is the good one. And we don't do anything at all. Okay. And then blah. Alright. Oh. Okay. We exit the process. Oh, finally. But what did... It's just because it exited? So let me see what does the exit code was. Exit code was 5. And what's that? It's an error because we don't have it anymore. Did I close it? No, I don't think so. Let me continue. Process is running false. Whoa. We created a process again. So we created a process again, and it should do it infinitely. 5. So everything is gonna go the same route. Session breakpoint. Go there. There you go. Oh man, this is so funny. We're just finishing, exiting, finishing, exiting. Okay, I think that worked. Alright, so let's see what we can do with that. So we know that we wrote the breakpoint and we are caching it. Now the thing that we have to do is to proper handle it here, because we know that we can do something more like if first first breakpoint is process first breakpoint something like this, and I want to say let me see how can we handle this first chance, second chance stuff. We don't care. I mean, we should always process on the first chance, I guess, because that's what we want. I don't know if we should allow. I mean, I don't think there's a problem with handling first chance or second chance, or I don't know. I mean, I think that's kind of stupid, but let me see. So this is the first breakpoint we don't want to handle, so we probably so we could I don't know, say something like I mean, we don't do with the same for now. We don't care too much about this, but we can do it. I don't know. We can do something like this, I guess. We're gonna have breakpoint count, and this is going to be for now we just need that, I guess. We don't need any more, but it's just for the sign-outs. We can do something like this: breakpoint count greater than 2, and we can go or probably this is more like breakpoint index and breakpoint count. So that breakpoint index, we can do this, breakpoint count or breakpoint index, I guess. Breakpoint index, there you go. And that way we just handle our own breakpoints, because the first breakpoint we don't care. So if we got an index, we can process it as needed, you know. We can say something like well, we know that we got the breakpoint. We know that the first we know that this breakpoint is going to be same. Probably what we want to do is to if div state breakpoint index equal to this state breakpoint count, this state breakpoint index 0 but 1, I guess. So we always process it and restart the loop, I guess. I'll assume that we can do that. So we serialize everything. And we can let's see, what can we do with this breakpoint stuff? Well, now that we know that we have a 1, we can say that for now, since we just have 1, doesn't matter, we can do something like display data. I mean, well, we So it's like uh, we are want to go the route on, where is it, continue to put the ban, continue tracing, oh, we have here the first chance, I think, deception first chance, continue tracing false, and we want to say something like we want to write a thing, so we probably want to here we want to, we will stop at currency in main servers time out. We want to do this same, and we want to original code byte, or for now I'm just gonna store it right there because we don't have any kind of any place to store it, so I think that's fine. Original code byte is gonna be like that. Here we're gonna use that to write that back. Oh, there you go. Just one. There you go. There you go. And then we flash it at the current address position. And there you go. This is all the same, I guess, but we have a caveat here, and the caveat is that once we get the exception, and we get to this part, the instruction has been already set, so that well, where is it in the scratch? This instruction is already, it has already been executed, so we are already past that instruction. So what we have to do is to basically like go up one instruction, and so we can reprocess it, and this is the magic of This is the magic of this is the magic of debuggers. And the thing that we should do is, where is it? Right here is before anything doing here, we are gonna how is it called? Get thread context. It's basically the thing that we had before, I guess. Yeah, basically want this. And the thread context is going to be from the thread that we're running right now. So it's going to be more like I remember the flat tracer. It's gonna be this state, then it's gonna be the main thread context, and this is context, and this is gonna be context, I guess. We don't know which context is gonna be. The context, I guess. Good. And I don't know if I like that. Well, no, it's because that way. Yeah. Okay, so we got that, and then we get the context, and once we get the context, we can have, if you remember, we got this whole crazy stuff here going on, you know. This is the construct structure for a 64 processor. 64 bits, they could be used to extend the context of, okay, this, we don't care about this. We have the context flags, and I basically want I think it's this one, isn't it? This is instruction pointer. Yeah. So we want that from the context. And we basically want to, since it's a 64, we want to move it in fact, I would like to test these ones because I don't know what they are. Probably they are kind of useful, although, you know, the problem is that this is just for 64, so probably want to do something with this. This is platform specific, handle each platform as well. Okay, so we're gonna get the thread context, process, blah blah blah, and the thread context. Oh, let me, I can do this right here, and we can set the reset instruction pointer. We can do something like this, I guess. And this is I just want to read this stuff because I don't know what's that. I just want to read it. And then what I want to do, and the reason I do is this because it's just one by. We have to move, I guess. I don't know. And that's kind of funny because I mean, how does the I mean if you remember, the instruction was something like 4 bytes, you know. In this case, it can be any, but in this case, it was 4 bytes. And scratch those 4 bytes. I mean, they were expected to be read, you know, as an instruction. So if we modify the first byte to CC, how does the process itself know that it's I mean, the instruction is not this, you know. I mean, probably because this instruction doesn't exist at all, you know, and he understands that the instruction itself is just 1 byte. I would assume. I don't know pretty much how does that work, but I would like to know. So because for what I've read from this for all these websites and this stuff, is that yeah, it's gonna be just 1 byte, and it's assuming that we're gonna get here, you know, in this place. So that's why I'm moving just by 1 back, so we can return there. And the point of this is that we are gonna move the context, and then we should set thread context back. Let me see. And I remember the aligning itself. Alright, so we can basically do the same thing. I'm sorry. And yeah, I remember looking at the context flags at all. So let me find the context flags. Oh yeah, here they are. Control flags, context flags. And what are the context flags? No, I don't know. There should be something that we forgot to read on the Windows NT header. But let me see if that works. If not, we can take it. We can look at it later. So let me see. Where did I leave? It was right here, and we just set it like, okay, you know, we got it. Set the thread. Here you go. So we got the thread, we set the thread back, you know. Now we have go back to the proper instruction to be executed, and then, you know, we say, hey, please write to this address. And, you know, probably I mean, we can use the thread context array API for using the current address position, you know, probably because this thing is gonna be moving, so probably we're gonna do context RIP, and this is gonna be treated as a bug pointer. Let me see if that works, and then this is the same. And you know, we can take a look at the registers themselves, so that we have all this stuff and look at it, you know. So let's see if we can do also that. And it's, well, you know, I can look it in the debug window, I guess. And this is debug this state. Continue tracing. And this is yeah, we have to have a way to reset the input, so we have a way to do it. Well, I just want to see if we can stop the tracer, you know, with this way. So let me see. There you go. Alright. So we basically wrote a bunch of code there, and we would like to see what we got. So let's go back here. Oh, and something that I forgot, which is something that we forgot to set the variables, the new variables. Probably can do this for now. Well, I think that's correct. And also right here, I guess I want to, well, process is running is false. It process is true. Continue tracing is true. Breakpoint index 1. Well, breakpoint no, breakpoint index equals 0, and breakpoint count for 1. Something like that. Something like that. And yeah. Provide user input data. Alright. So let's see what we got. There you go. Create a process. We output the debug string. We read it. We get the address. Process the memory. We flush the cache. And continue tracing. It's true. So we do it. Continue. Then we go to the next one. We load the DLL, which is fine. Then we load another DLL, we got a breakpoint, and the breakpoint index is the first one, so we are not gonna handle that. So we move the index. And well, this is kind of busted because yeah, the breakpoint count should be well, now I don't think well, we can do it this way, I guess. It's because that breakpoint is not gonna be set another time, isn't it? Yeah, so that's correct, but probably this is 2 for now because we don't set it to the for now. Let's say that we have that. Okay, 5, right, continue. We got the breakpoint, we have F10, we got it, we got breakpoint count 2, and breakpoint index it's 1, so we don't do anything there. Continue. F5, create thread debug event. So where's the other breakpoint? There was a missing breakpoint, I guess. There's no events anymore, so that's kind of crazy. Oh, and I wanna, well, another time. Create a process, and let's say that we do that. Are we not properly doing this, I guess? original code path is 48. That's true. And we know the interrupt code path C. We want to write the same address. We want to flush cache at the address. Continue. We got exception breakpoint. This is the first exception. There you go, another exception. That was crazy. And now it's 1, so we're going to enter. We're not going to continue tracing because we're going to stop. And then we're going to get a thread context for the thread. What about the thread context? Let me put it here so we can inspect it. So we have P1 home, P blah, 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 blah. We don't have anything there. We have context flags there, you know, that I don't know what that means. Let me see. We have the E flags. We don't have anything at all. We don't have anything that registers, which is, we have RIP and RIP. It's 0. Oh. So that's not good. I don't remember which one it was. Let me. Oh, we probably missed this. LC context flags. Let me find something about that. Context flags. This is not the thing. It's like, what the hell is this? No, I want context flags for the context. Thread context. This doesn't tell me anything about that. Or is it? It doesn't tell me anything about this. Let me see. Here are the context flags. And it's the only place that it's been referenced. So shall I look on Windows NT back again? I don't even remember where it was. So, oh, we have it open. Awesome. It's this one, isn't it? Awesome. Awesome. Let me go to context. No. 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 Okay, probably this. The following flags control the contents of the context structure. Context AMD64. RC bug exception read for following body specify the type of access in the first parameter. The exception required when the one. Jesus Christ! Who wrote this code, man? Who wrote this code? What? So these are the segments. The G segment. These are intrinsics. Write G word. These are all intrinsic functions to read and write to user TEB. This is the TEB and the PCR and the PRCB. Okay, cool. We have functions to read and write to the TEB. And what else is here? What else is here? Perform functions to perform one. 128-bit shifts, 128-bit multiply. Perform functions to move strings, bytes, words, and words. And this has all kind of stuff here. It has interlock things, a bunch of definitions. Okay, so let me go to the place where I was looking at, because this is the context. And yeah, this is the one we want. This is gonna get control, integers, segments, and the floating point, the debug registers. And yeah. So the thing that we missed here was that get me to the context. And it's the Are you ready, my dear? Yeah, okay. Again. Let's try again. Create a process, good. Load the alert, good. Load the alert, good. Load the alert. First exception, second exception. We get it, we enter. We say, hey man, get me everything, please. And it's the there you go. We got the context flags, the segments, the E flags, good. We don't have anything on DD blah blah blah. We have regs, all the registers till R9. From R10 to R15 we don't have anything. We have the instruction pointer, which is the thing we want. And you can see here we have this, and I believe that we can take a look and say if we scratch, here we go. Oh. No, I want this. Oh, no, man, what's going on? I cannot copy things. I cannot copy anything. Copy. There you go. My button C is not working or what? Control C. Okay. This is the register, which basically should be one past. So if we say we have the T context, and we also have this state where is the current process position here? Well, yeah, I know it's 1 byte, but let me copy it just to be sure. And there you go. Yeah, now we are sure that it's just 1 byte. So now that we are sure about that, the next thing that's gonna happen is correct because it's just 1. And oh yeah, and the thing that I was looking for is in the context, the last branch and all that stuff. What's that thing, yeah? Well, we don't have anything at all. We have the vector register, and we don't have anything at all in there, which is anything at all, which is all of this, I guess. Yeah, all the XMMM, all the SIMD registers. Okay, so it wasn't anything at all. Okay, we tried it. We set the context back. We write it back, and we say that we want to write it on the original code back into the register back. Hey, we got it. We flush the cache at the RIP for the handle process, and boom, we updated the breakpoint. We have the breakpoint count. We say, hey, get it back to 1, and boom. And since now we're not tracing at all, we're not gonna continue the tracing, and we're gonna go to F5, and hey, there you go. Awesome. And in fact, we can, just for fun, because why not? Let me close this, and just because for fun, instead of doing this, I'm gonna do basically I'm gonna put the registers so we can see what's in there, you know. So what I want to do is basically this. we can say registers at 0xp, and then we go that, then we say we probably want something like this. Probably we can do something fancy here. We can do something like this, and then something like this, and then something like this. We say, you know, get me all, oh no, get me all this. There you go. And please, I'm gonna do this, I guess. Courage return, I guess, something like that. I don't remember if it was, yeah, it was like that, I guess. I don't know if it works, but I'm gonna just say that word 64, replace it with nothing, and I just wanna copy this and say, well, you know, and I wanna replace this with this, and then this is gonna be, this is gonna be this and this and well, probably you want to do this. You know what I mean. You know what I mean. You know what I mean. Okay, so now all I want to do is to copy this back, and this is not gonna be that, this is gonna be this, and this is gonna be tcontext.rip RIP plus 1, I guess. And that it's that, and this is this, and all this. I'm gonna say that I want to change again Dort 64 to the context dot, oh, and I forgot something. Control A towards 64 space change for the context that are IP. Oh. Sorry. The word 64. No. The word 64 space 40 context dot. Yeah, that's correct. Yeah. Awesome. And it was missing one. Okay. Alright. And we'll need blah 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 blah. Basically, this is a comma, 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 comma. There you go. And we don't want that anymore because it was just less. Or are you serious? Oh, there you go. What? I didn't. So what's the format for U64? It's a long, something like that. Let me see if I can get it. Long. So you mean like what is X? remember if it was before or after. It was something like that. No, it was something like this. How it was done. Or we can say that it's a pointer, I guess. It's a pointer. Or I don't know if I can do something like lang. It doesn't get it, so pointer. If I say void pointer, so yeah, something like that, I guess. For now, because we don't have any kind of valid way to do this, I guess. And these are P's everywhere. All right. Let's try this. We are gonna basically print this out. Did we set a output debug string? Please tell me. Yeah, okay. F5, 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 and then a breakpoint. We set that. There you go. Awesome. Registers apply. It's Rex, RCX, RDX, blah blah blah. So hey, we got it. Yeah. Alright. So that sets us for good for today. Okay, so now please, if you have any questions, ask them and I'll be happy to answer them. It was a cool stream, isn't it? We set a breakpoint, and yeah. And you know, I like the way this is going, you know. I like this kind of new architecture that we set up, and I think that it's gonna simplify a lot of things, you know. So yeah, I think that's good. So yeah, please, if you have any questions, ask them on Twitch, Twitter, or on YouTube, and when I see them, I'll be happy to answer them. For now, I think that would be all, and I will see you all on the next stream.